Good evening, dear students. So let's start our class. Today we are going to make some practice today, together on from theory of equations. So before I start, please feel free to me any doubt you have, and please confirm that you are able to view the screen and hear my voice very clearly, dear students.
Yes, sir.
Okay. So make your pen and paper ready and start answering this question one by one. So this is the first question, what you see, dear students, in front of you. The question is that if 9 square root of x is equal to square root of 12 plus square root of 147, then what is the value of x?
So it's a 3.
You are getting it 3?
Yes, sir.
Okay, absolutely correct. Very well done. Appreciate.
Yes.
Good. All of you got 3? Disha, Srijita. Okay. I can explain you how you get 3, or Mohor, you can tell how you got 3.
Sir, I wrote root 12 is 2 root 3 and root 147 is 7 root 3.
Very good.
2 root 3 plus 7 root 3 becomes 9 root 3.
Correct.
Yes.
Exactly.
So
Yes.
equating we get x
And
equal.
yep, yep. Correct. Very well done. Other way also is that is another approach I can say.
Yes.
So what is given is that, so let me use a different color. 9 square root of x is equal to square root of 12 plus square root of 147. So let's make a square of both the sides. Then what we'll get? Here you'll get 81x is equal to 12 plus 147 plus 2 into square root of 12 into 147. Then what we get, dear students? 12 plus 147 is equal to 159. So from here what we get is that 81x is equal to 159 plus 2 into square root of 12 into square root of 148. If you make all these things, so that becomes 84. I am not spending time to calculate that one. So from here what we get, dear students, we get 81x is equal to 243, and hence we get the value of x is equal to 3.
Yes.
Is it clear, Disha? Absolutely clear?
Yes, sir.
Okay, Srijita, is it absolutely clear? Okay, maybe I'm not able to hear Srijita today. The next question, dear students, is this one. The real number k for which the equation 2x cubed plus 3x plus k equal to 0 has two distinct real roots in 0, 1 closed interval. How we are approaching this question? Actually, I would like to, tell you one concept about, you can use the concept of differential calculus to solve this particular problem. Okay. So, dear students, that a real number k for which the equation has two distinct real roots. So let us assume that fx equal to the 2x cube plus 3x plus k. Okay. So what we are taking, that we are assuming that fx equal to 2x cube plus 3x plus k. Now, if you differentiate, both sides with respect to x, what you are going to get, dear students? What you are going to get, that is equal to f dash x equal to 6x square plus 3. Correct or not? Now, 6x square plus 3 is always greater than 0. Correct or not, dear students? For any x being a real number, f dash x is always greater than 0. So this implies what? F dash x is greater than 0 for all x belongs to the set of real numbers. And dear students, when f dash x is greater than 0, then the function fx, means y equal to fx, is an increasing function. What does it mean by increasing function? This is a new piece of information maybe to you, is that, and because we have not discussed the application of differential calculus in details, so this is the coordinate axis, and let us take a function like this. This function is called an increasing function, y equal to fx. Increasing means what? Increasing means that as x is increasing, y is also increasing. If you see this curve, what I draw in red color, if you increase x, then you find that y is also increasing, right? Or you can get a, this kind of thing. That is also, as x is increasing, y is increasing. Or it can be something like this. All these type of curves are called increasing, And the property of increasing, function, is that if you differentiate that function with respect to that variable, that is x in this case, it should be always greater than 0. Correct? Why? Because there is a relationship with the coordinate geometry. Because if you take any point on this curve, dear students, and draw a tangent, the angle it will make with the x-axis is always an acute angle. And tan of acute angle is always positive. And tan theta is nothing but f dash x, if this is theta. But anyway, I'm not getting into that discussion at this moment because we have not discussed trigonometry, sorry, coordinate geometry of 2 dimensions. That's why I'm not getting into that discussion. But in brief, if you see that f dash x is greater than 0, then you can just conclude that, okay, y equal to fx, that curve is an increasing curve, or it is an increasing function. On the other hand, if you find that f dash x is less than 0, then you can say the function is a, it is a decreasing one. Correct. Means decreasing function will be what you know. Just for the sake of your information, decreasing functions will be something like this. Like this. You see, x is increasing but y is decreasing. Or something like this. Or something like this. In all this case, you see x is increasing but y is actually coming down, no? As x is increasing. So anyway, this is not part of our discussion. So what we get is that we found that then as f dash x is greater than 0, so we can say that fx is a strictly increasing function, or we can say y equal to fx is a strictly increasing function. Now, because of that, what happens? If it is a strictly increasing function, then we need to find the value of k, so that fx equal to 0 have two distinct real roots. That is not possible now. Why not possible, dear students? Fx equal to 0 can have only one real root. Why? Because if you draw the curve for fx, what it will be? The curve for fx could be something like this. Correct, na? Increasing, and it will not again come back. Again, it is not coming back and crossing that x-axis. You cannot get the root, na? Root means what? Where it actually intersects the x-axis. Correct? So as it is strictly increasing, that means what? It just cross only once. Okay. So it is not possible to have two distinct roots. Got it or not? So hence we get the option D as the correct one. Is it clear by everyone? Disha, Srijita, absolutely clear?
Yes.
Yes.
Okay, great. The next question I'm going to give you, dear students. This is question number 3, dear students. The question here is that the number of real solutions of the equation e power x equal to 5 power x plus 5 power minus x is what? So one thing I made a mistake, maybe in reading, it is sine of e power x, by the way. Okay.
Yes.
The equation here is that sine of, if I can give a bracket, it will be more clear to you, is equal to 5 power x plus 5 power minus x. Okay, shall I help you, dear students?
Yes, sir.
Okay, so let's now focus on that 5 power x plus 5 power minus x. 5 power x plus 5 power minus x. This is equal to what? We can write 5 power x plus 1 by 5 power x. Now let's see. Whenever you get this kind of information that 5 power x plus 1 by 5 power x, so what we can write this thing is equal to is that we can write is that 5 power x minus 1 by 5 power x. Okay. Um, okay, just a minute. Let me write little differently. So that we are going to write is that 5 power x by 2 plus 2, correct na? Plus 1 by 5 power x by 2 plus 2, correct? Do you agree to me? So a square plus b square, that means what? A plus b whole square. A square plus b square you can write is that a minus b whole square a minus b whole square plus 2 into 5 power x by 2 into 1 by 5 power x by 2. Do you all of you agree to me, dear students?
Yes.
So this implies this is equal to what? This is equal to 5 power x by 2 minus 1 by 5 power x by 2 whole square plus 2. Since 5 power x by 2 cannot be equal to 0, hence we can cancel that 5 power x by 2 and 1 by 5 power x by 2 here, correct? No? So what we get, dear students? From here what you can say is that this value, that 5 power x by 2 minus 1 by 5 power x by 2, that whole square should be always greater than equal to 0, correct or not? Correct or not? So from here what we can get is that 5 power x plus 5 power minus x is greater than 1 at least. So now if we apply this concept here, what you are going to get? This implies sine of e power x is greater than 1. Is it possible? Impossible. Sine of anything is always less than equal to 1. It cannot be greater than 1. Right? So the number of real solution to this equation is now become 0. Correct? So which is impossible. Correct, my dear students? Which is impossible. That means number of real solutions, number of real solutions to this equation is 0, and we get the correct answer as option B. Any doubt in understanding this one? Because you need to register all these concepts in your mind very clearly, dear students. Okay? Absolutely clear?
Yes, sir.
Okay, dear students. So um, this question, what I'm going to give you, so that is a question related to here I use the concept of complex number as well. Okay, so please solve this question. That is question number 4. So dear students, I would like to make this question is the last question for the session now. Uh, and then again we will resume classes tomorrow. So please do let me know how you are approaching. So if you look into the question here, is that the equation here is that z square plus az plus beta equal to 0. Correct, no? Now, alpha and beta be real and z be a complex number. Now let's assume z is equal to x plus iy. Let z is equal to x plus iy. But what is given? The real part of z is equal to 1. Now, as a real part of z is equal to 1, that means x is equal to 1. So we get z is equal to 1 plus I into y. Correct, not dear students? Now, let's apply our fundamental understanding. The complex roots are conjugate to each other. So that means if 1 plus iy is a root, then 1 minus iy is another root. Because we know the complex roots comes in conjugate pair. Correct or not? So from here what we can say is that 1 plus iy and 1 minus iy 1 minus IY are roots of Z square plus AZ plus beta equal to 0. Now, if you look into this thing, we know what? The product of the roots equal to beta, na? If you look into this equation, the products of the root is beta. Correct?
Yes.
So
Yes.
product of the roots is beta means what? So we can write 1 plus IY into 1 minus IY is equal to beta. So this implies beta is equal to 1 minus I square y square. That means 1 plus y square. 1 plus y square should be always greater than equal to 1. Because y is a real number, right? This implies b is greater than equal to 1 for all y belongs to the set of real number. It will be equal to 1 if y is equal to 0. Correct or not? So from there, what we can conclude, dear students? We can conclude
And
that,
beta belongs to 1 to infinite.
I'm sorry,
Then beta will belong to 1 to
1
infinite.
to infinite, and eventually we get the correct option C. So we conclude from here is that beta belongs to, actually, 1 to infinite. Actually, ideally speaking, it has to be closed interval 1 to infinite. But you need to choose that option which is closely matching with the solution. Correct now? So that is why eventually you get the option C as correct. So dear students, so I am concluding the class now here. And we will resume from the next class. And in the next class, we will discuss some questions from trigonometric functions. So please revise trigonometric functions, and in parallel, please appear for the DPP on units and measurement of physics and some basic concepts in chemistry from chemistry. Okay, thank you, dear students. See you tomorrow again. Bye.
Thank you.
Thank you.